Hello and welcome to another Sonic Lab. Today we're looking at the brand new Pittsburgh Modular Lifeforms Voltage Lab. This part is the Voltage Lab, which is the sort of West Coast synth voice. You're probably wondering why have you got it set up like this, because this panel here is the touch controller and a number of other things besides. The reason I've got it set up like that is because, as you can see, it's a desktop unit. So if I had it upright, the front panel would be facing this way, which in our setup would be really difficult to film, because if I wanted to film it, I'd be kind of in the way of the camera. So in case you're wondering. So what is the Lifeforms Voltage Lab? Well, Pittsburgh are very excited about this because it's essentially a very much more of a West Coast vibe than the 3900. It goes even further. And I hesitate to use the term West Coast because I know a lot of people get a bit upset about the fact that it's not really about that. There's no division, and I'm not saying it's just a term I use. East Coast is generally more subtractive, your classic kind of Moog type voice filter, VCO into filter, VCA, that kind of stuff. Whereas the West Coast is more of a sort of complex oscillator, low-pass gates and function generators. It's just a different type of, or different set of ingredients in a synthesizer. And that's what they've got here. This is more your classic West Coast. And first of all, first things first, nice to see they've got the patch bay down the bottom. I like that because it does mean that when you get a complex patch, which you inevitably will, perhaps more so with West Coast stuff, you end up with a lot of the controls being obscured, and not so in this case, although obviously you're going to obscure the actual touch panel. Okay, you know, swings and roundabouts, what can I say? But what we have is a primary oscillator here, and the primary oscillator gives us sine, triangle, saw and square, but we also get the ability to wavefold and warp those and change the asymmetry and the axis of the waveforms. In kind of layman's terms, masses of harmonic content from those simple waveforms. There really are there is a lot more harmonic stuff there. One thing that they've done, which is apparently very hard to do, and this is something they figured out, is to figure out how to fold, saw and square, and also warp them in a kind of sonically meaningful way, and they do sound very interesting. We'll get onto a bit of that later. There's also a secondary oscillator which just has sine and an alpha wave, which is sort of warps through different types of waveforms. We've got a Midi Control section here, an arpeggiator. We can assign these oscillators to MIDI or not, depending on how we want to do it. Then we get onto the function generators. Now these two, the function generators, you may be familiar with this kind of thing. Essentially, it can be either an LFO with a variable wave and, you know, saw up, saw down, sine, or more of a pingy thing, or it can be a kind of envelope, one shot. And there are two of these with various other controls as well, and lots of control voltages for the different parameters there. Then we get onto the dynamics controllers. Now these are more your kind of low pass gate stroke filter, but they're not, I mean, low pass gates are not generally filters, but what they've done is they've come up with a new concept. They've sort of pushed the boundaries a little bit. They've taken the traditional method of doing it, and what they've done is they've added a resonant filter in there, so we've got resonance on the low pass gate, and as they explain it, and I don't profess to be an expert in this, you generally have two kinds of Vactrals. You have a pinging kind of Vactral, which is this more snappy, sort of plucked sort of sound. Then you have this sort of more tubby type of Vactral. These are their terms. So with this, we're able to actually morph between the two, and we can also switch the modes. We can also with this little orange light, it tells us whether or not we are in MIDI mode, or we can have trigger. And then we've got control over the dynamic CV and the responsive time. And there are two of these guys. Then at the final bit at the end, we've got a little analogue delay, bucket brigade delay, which kind of adds a little bit of extra flavour into it. This is actually mounted in their own case, as you can see, and I've got it upside down. This whole system is purchasable set as an entire thing, or if you like, you can buy this bit as a separate thing. And they say they will be bringing this out in a sort of desktop form, a bit like that guy over there, which is the Pittsburgh Modular SV1, which is a really good sounding East Coast synthesizer voice. So I'm going to try and dive in and give you some kind of the skinny on what you can do with this thing and what to expect. There are a lot of functions in here, and it's quite unfamiliar territory for me, but hopefully I'll be able to give you a kind of rough overview of what it brings to the table. Right, let's up this. Probably the simplest patch to set up is we've got the MIDI normalized into the primary oscillator. I'm running it from this MIDI keyboard here. So I'm also taking the gate output of the MIDI section and coming into the mod CV on the patch bay. Probably get a little bit closer there. And I've set that modulation source to be amplitude because primary oscillator has a little VCA built into it, which is worth knowing. It's quite handy. And I've just turned the gate up there. So that means the gate will just open the VCA on this. If I wanted to make that a little bit more expressive, I come out of the function generator. So that's also in MIDI mode. You can see I can switch that in just by pressing the button, function button. So now I've got a little release envelope controlling the primary oscillator. So let's have a look. Classic kind of wave folding, which as you'd expect on the sine wave. And also if I hit warp, very similar though, not quite extreme. This warp circuit is a sort of an additional circuit and we'll see what that really does in a moment. Triangle wave. Tracking feels very good. And there's a nice bit of weight down there. Again, wave folding. And we can modulate this timbre via the patch bay, so no problem. In fact, we could do that very quickly. Just take this split cable, go into the timbre, and then so I'm having the same envelope modulating the timbre. Anyway, we'll come back out of there. I'm not going to use that. Next waveform is warp again, and then we'll go to the sawtooth. We've got the wave folding, which is kind of, it's all right, but then when you engage the warp, this is where it gets really interesting. It's almost phasey, kind of woody sort of quality. So if I come out of the second function generator, come into the timbre modulation. Very interesting. Anyway, we'll take that out of there. Now let's try the square. We've got octave switches here on the little MIDI sections, worth mentioning. Some interesting points along here, but engaging the warp. Quite interesting tones we've got there. Now, so let's just listen to the secondary oscillator. I'm going to come out of there. I'm going to use a dynamics A. We'll come out of A into out and then into here because that will just give us a. Start with our sine wave. Then we go to the alpha wave, which starts with a triangle and then morphs through into a sort of square. And then we can combine those. We can also sync these waves. Lovely sync as well. So between them, these two oscillators have got an awful lot of timbral possibilities covered, and because we can manipulate those control voltages really nicely, we've got other possibilities. So there's also some normalizing going on between the secondary oscillator and the primary oscillator. So I press this button here, this potentiometer routes this through to this routing here. So if I go to FM mode, I've got a very little amount. And that's one thing, this is actually very sensitive. It took me a long time to find the right amount that would just be vibrato, but we can get FM going on there, and we can go into waveform modulation. So now we're actually just scanning through the different waves available. Then we've got amplitude. We've got a bit of delay on this patch. It's quite nice, this. And then we've got ring mod. So yeah, loads of additional routings here. Then we can combine wave and FM and wave and amplitude. For some sort of bird type noises. So lots and lots of possible modulation routings there without actually using any patch cords, even though there are quite a lot of patch cords on this patch. Okay, so let's have a look at a few other elements of this synth. I'm just going to run this sequence here. Come back to here. So I'm basically listening to the oscillator, primary oscillator going into function generator B, which is then controlling the dynamics controller. So you've got a low pass gate mode, gives us some real pluck. This is being controlled by MIDI because you've got the light on. This is a combination of pluck and low pass gate, and you can change the response to really sort of blat it out. Then we've got VCA mode, and we've got the filter mode. And we can add resonance here. Got a bit of delay on this. I'm just in trigger mode, there's no sustain portion of this. But then I've also got the secondary oscillator. And I'm using function generator A as an LFO. It's in sync, and I'm modulating the FM. Now we can have this dynamics controller be MIDI triggered, or we can have the function generator being MIDI triggered. If I make the MIDI trigger, then what basically happens is the oscillator, the cycle is reset on MIDI notes. It's like having a reset LFO. Take that out again. And we can listen to just how we've got the response time, which can be pointy or more sort of curved. That's as fast as it goes, which isn't quite as fast as I'd like. It would have been nicer to have that a bit faster, maybe more into audio rate, so we could use the function generator as a sort of another oscillator. I'm fairly sure the 3900 microvolt allows you to go a bit faster on these, but I'd have to check. So function generator and B, they are very flexible, and they also can be synced up and linked together in unison mode, so that you have it triggering on the rise part or on the fall part, so you get these kind of more complex things. It's a pretty powerful little set of functions actually, and they're very well thought out. We can also affect the rise and the fall of the CV via these amounts here, and we've got the difference between the two and the logic. Coming back to the dynamics controller, we can get that quite resonant. And we should just listen to the delay. It goes up to about 750 milliseconds. And you get all of that regen stuff. You can actually control the time of the CV. Would have been nice again perhaps to be able to have that as either a stereo effect, because we've got stereo output on the utility section, more on that later, or to be able to have a longer delay so that we could build some more interesting kind of textures and whatnot. Right, so we've mixed it up a little bit here. I flipped this up a bit, and what I'm doing is I'm going to show you the Lifeforms Touch Controller. I've got a patch set up here, which because I haven't got right angle connectors, because that would be a really good idea in this case. In fact, there's a great video by Luke Pop, which he goes through a lot of the features of the Voltage Research Laboratory, and he's using these great right angled patch cords, but I haven't got those, so we're stuck with these. So essentially what we have is a touch keyboard here. There are 10 pads, each with its own control voltage. Now there's two rows of control. There's a control voltage A and a control voltage B. The pads can be split into two halves, so you can have two 5-pad keyboards. We've got, if you can see here, it's a bit tricky to see, but we've got a left and a right output here, but then there's also a sum output, so we can have them control separately. There's a gate output for these. There's also control A, control B, and then there's a y-axis, which basically means we can control something with the movement of the finger. The touch controller is actually quite handy because what it actually enables us to do is, as well as use this as a keyboard, we could use this as a way of basically presetting up to 2 control voltages. These control voltages are unquantized. There's no kind of like quantize or stepping, and I guess that does bring up a thing that would have been nice to have in the Voltage Lab, which is a quantizer in there so that we could easily snap it to a scale, but I guess you can't have everything. So coming back to this, so we could have 10 pads which had, 2 control voltages on each, which might be the pitch of each oscillator, it might be the speed of the function generator, or something to do with the dynamics controller. There's also lots of things it could do. Or we can have it set up to be 2 5-pad controllers, because in this way we can have it in single mode or in duo mode. There's also a little animator in here which allows us to record steps and then play them back, clock from an external source. I'll go on to that. So how would this work in practice? Right, so I've got a sequence running on the Arturia, which is just MIDI into the primary oscillator pitch and also into the function generator. So the signal flows out of here into function generator B and then into dynamics controller A. And I've got a lot of resonance there, add a bit of delay. Get the timing about right. Then on the key bed, you see I've got this synced, secondary oscillator synced. Nice. So basically I've got 2 control voltages coming in. I'm just happen to use the Arturia to control one of the oscillators, but I could, like I say, I could split this so that each of these pads could be a separate keyboard, effectively, a 5-note keyboard with preset control voltages. Now I'm also taking a clock out, well actually let's do this. So what I can do is I can actually record steps by pressing and holding the mono mode, because this mono makes this 1 key bed, duo makes it 2 5-1s, and then there's a reset. So now I can take the clock out of my Arturia and I'm going to press play on that. So you can see I've recorded those steps. Or I could record so lots of potential there for kind of for performance and that sort of things. Yeah, it would have been nice to have a quantizer because these, as I say, they're all sort of free-flowing CVs and there's no way of presetting them. But a lot of ways that you can use this quite creatively, for preset voltages, all kinds of things. And it's really actually opens it up into a kind of almost bitimbral kind of thing, because there are effectively 2 full signal paths, one for each oscillator. you know, so you can actually get, you know, opposing lines out of it. That's I guess one reason why it'd be nice to have stereo analog delay, because we could have left and right signals and whatnot. It would have been nice to have a couple more utilities in there. Another little section here is the utility, system utilities, which is at the top of this module next to the keyboard. We've got A and B input, so like sum to 3 outputs. So it's kind of like a cross between a mult and a sum. And then we've got headphone output, stereo, in left, in right, line output with a master volume control, and there's a volume control for the headphones as well. It's kind of handy. There's all this space here. So what would be nice is to maybe have a quantizer, or one thing that I would have liked to have seen was a mixer of some kind, because currently the only way I can attenuate the signals is via going into the 1 and 2, this balance between the two. So effectively, if I move this all the way over, you won't be able to hear the input 1, but so I can attenuate it. Same on this guy, I'm hearing more of input 1 on the dynamics controller. So that's gone. I'm turning that down. I think the combination of these two units make this a really lot of fun and gives us a lot of potential for synthesis. And granted, if you're not a West Coast kind of person, then it's going to take you a little bit more time to explore. But some of the tones you can get out of this are really pleasing, and there's a lot of depth and weight. The oscillators do sound very sort of feisty. A lot of the harmonic richness, our ears are more tuned to picking out resonance and filters to get those harmonics. Using the complex oscillator approach, it's a very different kind of way of getting those timbres and sounds. So it does take a little getting used to. But if you're already in the zone, then yeah, fill your boots. Because a lot of the things that the Pittsburgh people have done, you know, you haven't seen this kind of stuff before. You know, they've solved this issue with the wave folding and warping on the saw and the square, which provides some very interesting timbres. They've also given the dynamics controller this kind of variable Vactral vibe. God, that sounds like a lot of alliteration. So we can get a combination of things, and also added resonance, which means that we've got a more traditional filter. So some really impressive stuff. So the price of the Voltage Research Laboratory is $1,500. So it is a premium product, but it is absolutely stacked full of features and functions of a West Coast variety. It is also going to be possible to buy them separately. This is going to be in Eurorack version, I believe, is $899. There will be a black box version of this as well, which is a desktop version with a built-in power supply in a small case. There's also, you can buy the Touch Controller, Lifeforms Touch Controller, separately. That is $399. And the case, I believe, is about $350. And this is a rather pleasant walnut finish. So you can buy the whole system or components of the system. I mean, yeah, it's a premium product, but as we've seen with a lot of Pittsburgh stuff, it's really good quality. You know, the Black Box SV1, fantastic value for money. Yeah, not the cheapest, but sounds great. Same with the Voltage Lab. Voltage Lab is certainly not the cheapest, but it sounds great, and it really packs the features into a very small space. I mean, and that is possibly its only downside. As I said, it can be a little bit microscopic to try and fiddle and get all the stuff, but the sounds that you can get from it, the variety of harmonics, all the functions and features, really very impressive. Anyway, that's it. Thank you very much for watching. We'll see you next time.